So here we are, confirmatory factor analysis number 2, and brief recap of basic rules that are related to model building. We have covered 3 basic rules for structural equation models such as correlation, regression, and path analysis in previous lectures. And last time we have covered also 3 new rules that are closely related to confirmatory factor analysis. So let's go for these rules only for recap. So if we have confirmatory factor analysis, so we are expecting that all loadings are estimated if theory is expecting that some loadings are 0, and it is quite often in CFA, so this loading won't be included, so we would exclude some loadings. I can skip to the example of a 2-factor model, which is on slide 8, and you can see that, for example, here it is expected that factor 1 is related only to first 5 items, and factor 2 is related only to the next 6 items. And there is no so-called cross-loading, for example, for the first factor and the 6th, 7th, 8th, etc. items. So it is expecting, according to theory, that there is 1 dimension and 2 dimensions, and they are separated. So that's the rule number 4, and application of the rule number 4 in real life example. Let's go to next 2 rules, and the rule 5 say that if you are applying confirmatory factor analysis, then variances and covariances between endogenous variables and covariances between exogenous and endogenous variables are never estimated. So if I go down once again to our picture, so if we apply this rule to this picture, so it says that no 2 double-headed arrows can be present here, only one-headed, only loadings, according to rule number 4, and according to rule number 5, covariances here are forbidden. And also what is forbidden is to estimate variances for endogenous variables. For these variables, we are estimating variances for its random errors. So for these parts, we are estimating variances, for these parts, not. The same style can be applied to these factors, as factors are exogenous. So for factors, once again, we are estimating variances. So here we are estimating these 2 variances, no variances here, and 11 variances for random errors. So that's the application of rule number 5. And the last one rule, we have applied this rule last time in 2 different styles. This rule says that if you have some latent variables, it is necessary somehow to fix the scale of this variable. There are 2 options for this fixing, or 2 options which are quite common. One is that I would take one of endogenous variables, for example, the first one here, as the marker variable. It is called by this way. So it means I would take this factor loading fixed at some constant. Usually this constant is 1. So I would assign the value 1 to this factor loading, and the scale of the factor will follow the scale of this first so-called marker variable. Another option, which is alternative and default in JASP, say that you would take the variance of this factor as a unit or another constant, but mostly value of 1, and you would fix the variance of this factor variable. Once again, in spite of the fact that it is the default in JASP, it is slightly less applied, so that's why we would try to apply this fixing of factor loadings. So that's the rule number 6. And these rules should be applied to all CFA models to avoid problems. Fortunately, I must say that most of software packages, including JASP, are so clever that they usually apply these rules automatically, but some of software packages maybe do not recognize all these rules automatically, so you should be familiar with these rules. Okay, so that was brief recap how to build up a confirmatory factor model. And now we can switch into models with 2 factors. So this is, I would say, the second simplest model if we are continuing discussion as we started the model with only 1 factor. I would only briefly recap if I go back to our previous computation. If I remember well, it was your own practicing that you tried to take the model for variables A47D, A47A up to A47E. And if you apply the model for the set of these original 5 variables, it was expected they are measuring left-right scale. We found that at least some improvement can be made. I would like to repeat that we try to read the table called Modification Indices. And according to this table, if we would take 2 items, A47D and A47E, random errors, and link these together, chi-square would decrease by nearly 50 points. Original value of chi-square test was, if I go up 75, and if I go down by 50 points, so I would take 2/3 of original value and my model would be much better. So maybe it would be good to modify my model by this small change. It means to link these 2 random errors for A47D and A47E. So that was recommendation by Modification Indices. I would like to recap that if you start to modify your model, not only modification index should be the reason, but you should also try to read out items, so it means substantive meaning of these items. And if you feel that these 2 items are closely related by their meaning, and this relation is something more than what is present in common factor, so then you would add this link. So according to our discussion, we have decided to modify my model, and as we changed the model, so all these characteristics of the model, such as CFI, TLI, etc., were slightly improved, and this was the last model. I will only recap that if you like to add these correlated errors, you would go here into model options, and here by clicking on A47D up to A47E, you link these residual errors together. So this was the last model we have covered last time. So I would close this dialogue. This is some copy, so we don't need it. And now we would go further, and we would take 2 factors. So I would take previous factor A47A, B, C, D, and E. So this would be our first factor measuring left-right scale. And our second factor will be for the next 6 items. So it means A47F up to A47K. And these items are expected to measure conservatism and liberalism scale. So we will take these 2. And before we start real-life computation, I would like only to add one small comment. In the same style as we discussed last time about the first factor, and we evaluated the model for the first factor, it would be nice also to take these next 6 items and to prepare maybe some improvement for this model. So we would omit this part of data analysis, but of course it is only caused by not sufficient time for our data analysis, but if we would perform our data analysis properly, so the next step wouldn't be to perform two-factor model, but first of all to take these 6 items and prepare one-factor model, and then take these 2 maybe slightly improved models together into two-factor solution. So once again, warning, we would skip this step, but it would be good to follow also this next one-factor analysis for next 6 items. So let's go to two-factor model. And once again, this is the definition. So we are using KSSP data file and items A47A to A47K divided into 2 scales, 5 items and 6 items. And our main question here would be if we would prefer the model in which 2 dimensions are not related at all. So you cannot see any covariance, any 2 double-headed arrow here between factor 1 and factor 2. So that's the first model for discussion. And the next model, which would be a competing model, is the model which is expecting there could be some relationship between left-right scale and between conservative liberal scale, so it means between factors. Maybe before we start, it would be good if you try to estimate what would be our result, whether this model with no relationship for left, right, and conservative liberal, or whether the model with relationship for these 2 concepts will be preferred by our analysis. As we know about these data from EFA, so maybe you can help me to estimate the result of our analysis by CFA. So what's your opinion? Would we prefer the model with unrelated factors or related factors?
I suppose it was the related factor.
Okay. As we know from previous discussion for EFA, that these 2 factors are related quite closely. So the main reason why we will try to take these 2 competing models is that in quite a lot of statistical data analysis based on CFA, we are comparing these 2 models. So it means related and unrelated factors. And here we are quite familiar with a well-known fact that we would expect, especially in the Czech case, that this relationship would be quite strong. And we would, I hope so, by this comparison, recognize that CFA can very easily show that this model is much better than the previous one. So that's all. First model that we would try to compute would be this model. So it means no relationship at all. Unfortunately, JASP would force us from the beginning to correlate these factors. So we would need to overcome default in JASP. So we would need to say no relationship should be here. And then we would once again go back to the default in JASP. So by default, JASP is expecting that if you have more than 1 factor, these factors are related. So let's go to our computation. First of all, I would take our previous model. So it means model with correlated errors for A47D and A47E. Once again, if you go into model option, you need to define these 2 items for which you expect correlated random errors into this right window for residual covariances. So I would take this as my previous setting. So I would take a copy of this model from previous lecture. So that's the first step, duplicate the analysis. I would change the title only slightly. So currently we are preparing two-factor model and uncorrelated factors. Uncorrelated factors we are expecting. So that's the first change of the title, copy of the previous model. And first step we would need is that we would ask JASP not to correlate factors. So if you go into model options, once again, you can click here to the second option, which is saying, are you assuming that factors are uncorrelated? And I would say yes. So I would check this box, and here I am assuming factors are uncorrelated. And next step I would also perform is to change factor scaling. Once again, this is fixing of scale for factors, and I would change it to marker variable style. So marker variable and assuming factors are uncorrelated at all. So that's the first small change for model options. And the next, what I would change is that I would add second factor to my model. So I have here factor number 1. Maybe I can call it as it is left-right. So I would type it is left-right. And if I would like to add one more factor for next 6 items, I need to click on plus here, just under this list of variables, including the first factor. And I can once again assign the name. So I would call it a libcons, a liberal conservative. And I would need to move variables A47F up to A47K. So if I move all these variables into the second factor, in a few seconds, maybe more seconds on my computer, I would get results for this model with 2 uncorrelated factors, left, right, and liberal conservative. Once again, the picture for this model can be seen on slide number 8. So I'm expecting these 2 factors unrelated. Only small change added from previous lecture is that these 2 random errors are correlated. So here it should be added also double-headed error for these 2 random errors. So here we are, still not computed on my machine, so I hope you can see results, and maybe before my computer will finish result, you can read out, maybe somebody, what's your results. It means CFI, TLI, RMSEA. Now currently it is on my computer, so there is no necessity for you to read out, so I would read out for you. So we can compare our results, but for my computer I can see that CFI is 0.85, TLI is 0.805. And my question to all of you is that if you can see such results for CFI, TLI, whether my model seems good or not, whether there should be some modification, or whether everything is nice and we can continue and read other results. So what's your proposal?
It seems good.
Sorry?
It is good.
It is good if TLI is approximately 0.8, CFI is approximately 0.85. What was a recommendation that we discussed repeatedly during lectures? What is recommended threshold for these fit measures?
CFI should be above 0.9.
Okay, and now currently CFI TLI is below these thresholds. So maybe there could be some problem in my model, I would say. Okay, let's go further and read the rest of results. RMSEA, once again, recommended threshold 0.08 to be below. So it is fulfilled 0.078, so nearly the border. And SRMR recommended value below 0.05 and here 0.111. So at least according to SRMR and CFI, TLI, maybe there are some problems which are present in my model. Of course, that maybe these problems can be related to the second dimension, as we didn't prepare any special model for the second dimension. So it could be one problem. But maybe the problem could be that it is not good to expect that these two factors are unrelated. So it means maybe it would be good to switch to this model. We would make the switch in next minutes, but I would go once again back to our results. So here we have some recommendation that maybe some modification of the model should be performed. And if I go to the table of parameter estimates, and especially if I ask for standardized estimates, they are not present here. So if I go down for additional output, I guess, no, it's for advanced, sorry for that. Yeah, here it is, standardization, and I would ask for standardization all. So all these tables would be modified and there would be one column with standardized results. So if I wait a minute, I would get these slightly modified results with standardized estimates for individual parameters. So I would go here. So here it is. So I can read very easily that for the first 5 items, so it means for left-right scale, these standardized estimates are quite good. General recommendation is that these standardized factor loadings should be approximately 0.5 or bigger. So only the first items is slightly problematic for the left-right scale. For liberal conservative scale, you can see that quite a lot of these items are only weakly related to the factor, as these values such as 0.45, 37, 22, 31, and 38 are quite low. So maybe the problem which is present in my model is that this liberal conservative scale is much worse than previous left-right scale. It can be one problem. So only if we go into detail, once again, we would first of all perform one factor model for liberal conservative scale and maybe slightly improve this model. Maybe we would omit some item, maybe we would need to link some random errors, etc. Once again, we decided to skip this step for today, but it would be also a good step according to these results. We can go down and you can also find that there are some recommendations for changes for my model. There are 2 separated tables. One is called cross-loadings and one is called residual covariances. So it means that current proposal, as we have 2 factors, is saying I can take cross-loading, so it means from factor 1 to the next 6 items, from factor 2 to first 5 items, so these would be cross-loadings, and I can also link these random errors, not only inside one factor, but also across these 2 factors. It could be possible modifications. If I go slightly up and read result for chi-square test for this model with 2 unrelated factors. So here we are. I can see that the value of chi-square is 412 points approximately. And if I go down to this last two tables of modification indices, I can see that the biggest improvement would be to link left-right scale with A47J. So it means it would be factor 1 with A47J. So this cross-loading, if it would be added, it would decrease chi-square value by approximately 50 points. It is not too much if the original value of chi-square is more than 400 points. So maybe this modification wouldn't improve my model enough to be good. So maybe that these recommendations for modification indices currently are not the best one. Unfortunately, and don't ask me why, I'm not just producer, no table here in modification indices section offer the option what could be my results. It means what could be the improvement of chi-square if I would link these two factors together. So if I would add covariance for factor 1 and factor 2, there is no such output here. But once again, as we are discussing about two competing models, unrelated versus related factors, so our next step would be to compute this model and compare these models not automatically by these modification indices, but we would compare these two models visually in our outputs. So first of all, I would like only to remember this value, approximately 400 points for chi-square, and for CFI TLI approximately 0.85 and 0.81, and also for SRMR the value which was critical was 0.11 approximately. So these four figures should be remembered for this first step, and we will take this two-factor model and change it to correlated factors. So I would make the copy for this model. So if I click here to green plus, I would make a copy. I would change the title for this new model. So we would take two factors that would be correlated. So I would slightly change the previous title. So here it is. So we have two-factor model with correlated factors. And the only small change we would perform would be that I would go down to model options. And here, once again, I would go to checkbox for assuming factors uncorrelated, and I will cancel this checkbox. So I would be expecting that factors are correlated. So that's the first change for my model. And once again, I have just added this covariance for these two factors in my model. So that's all for this comparison. And you can see that chi-square, if you remember well from previous discussion, it was more than 400, is currently approximately 200. So it is 1/2 of previous value. So this model is much better. It doesn't mean it is good model, but at least it is much better than previous one. So that's the model fit. You can also see the change for degrees of freedom. I have added one parameter, and that's why degrees of freedom decreased by 1 unit. So here it is 42, and previously, if I go up, it was 43. So that's correct computation in JASP and correct understanding for degrees of freedom. So here it is. I will make it bigger. And now we can go to the next results for my current model with related factors. And I can see that CFI is currently 0.93. TLI is 0.91. RMSEA is approximately 0.05. And for SRMR, I can see the value 0.03. And now my question to all of you, and once again, if somebody can help me, it would be nice. The question is, do you accept this model? Seems good or not?
This is way better than the previous one, I would say.
Yeah. At least, once again, according to these classical fit indices such as CFR, TLI, and fit measures for errors such as RMSEA, SRMR, this model seems quite good, and we would accept it as a model that can be applied to my data. Once again, warning that maybe it would be much better also to improve the model for the second dimension, so it means for liberal conservative scale, and maybe the final model could be slightly better. But according to classical recommendations, this model can be accepted. Once again, I would like only to recap that for these slightly complicated models, it is impossible to evaluate chi-square test, as this test is quite strict, and it would usually for CFAs do not accept our model. As you can see, p-value is very, very low one. So that's why we are using as alternative these additional fit measures and other characteristics such as RMSEA, SRMR, etc. So that's the first comparison of these two models. Last one comment for direct comparison of these two models would be that if we would like to compare these models by some special criteria that are prepared for these comparisons, we would take AICs and BICs and compare these values. Once again, the rule is that lower AIC or lower BIC means better model. At least the difference of 5 is the sign of the better quality of the model with small value, so you can compare these AICs or BICs alone. So that's only the last one recommendation and recap from previous lectures. And now I would go down and of course we can check once again tables for modification indices. Once again, the chi-square currently for this model is approximately 200 points. And if you can see these recommendations here for the cross loadings as well as for linking of residual errors, so you can see small minor changes that would add change by 30 or 26 points. But currently, it seems to me there is no necessity to modify this model for the first insight, so we will take this model as it is. And I would go once again up, and the last one result that we should interpret substantively is the result for this relationship for these two dimensions. Once again, left-right scale and conservative liberal scale. And if you remember our results with the same data for exploratory factor analysis, so if we rotate it by oblique rotation, these factors, so this correlation was approximately 0.6. And we can confirm these results currently by this table, factor covariances. And if we take a CFA solution, so left-right scale and liberal conservative scale are correlated by 0.578. So these results for EFA and CFA are quite close. It must be quite close. And it says that correlation for left-right and liberal conservative is quite strong one. So here we have 0.6, so quite strong relationship for these two dimensions. And as the value is positive, and original scales are based on items that if you agree, so it means small values are left-oriented people, and for liberal conservative, small values are for those who are conservative. So it means substantively that left-oriented people are mostly conservative, and opposite is also true. So it means liberalism is in Czech environment related to right political orientation. So that's substantive information which is based on this correlation between these two factors. Once again, I'm currently discussing about factor covariances in standardized version. So it means it's not covariance if it is standardized, it is correlation. So correlation coefficient for these two latent variables is approximately 0.6. So that's another output. And last one discussion we would briefly go into would be devoted to so-called residuals. We didn't discuss about residuals in CFA or path analysis previously, but there is also one more diagnostic tool in structural equation models that can help to improve your model, and that's diagnostics of residuals. I hope that you remember some previous discussion about residuals and its usage for linear regression. So residuals in linear regression can help you to identify outliers. They can help you to identify such phenomena such as heteroscedasticity, autocorrelation, etc., etc. And the same style of this diagnosis of residuals can help also in structural equation modeling. Once again, I would like to recap that structural equation modeling is only generalization of regression and factor analysis into one common model. So what is the meaning of the word residual? What does it mean, residual in structural equation modeling? So first of all, if I'm computing some structural equation model, I'm using not original data matrix. So these models are not computed on this data, but first of all, I would take these values, I would compute covariances or correlations between these variables, and it would be input for structural equation model computation. So first of all, my input for SEM is covariances or correlations between individual variables. So that is what I would call observed covariance matrix. And if I compute my results, such as I have here these individual coefficients, so it means these factor loadings. According to these factor loadings, I can recompute this covariance or correlation matrix for individual variables, and this would be computed or modeled covariance matrix. And residual is only the difference for observed and modeled covariance matrix. So it is, in other words, the description whether my model fits good to my data, but not on general level. So it means it's not one figure, but for every point in covariance matrix, I can try to find that there are some problems in my model. Ideally, all these residuals would be zero. So it means that my observed covariance matrix would be the same as covariance matrix which is generated by my model. Of course, that this ideal wouldn't be usually followed in a real life analysis, but at least I would like to have small residuals at all. And I can use JASP or of course another software packages to find the values for these residuals and to identify possible problems for my model. So there are two options in JASP where we can find these residuals. So I can go here first of all into this additional output, and here for this additional output, I can ask for output which is called residual covariance matrix. So I can click here, and there would be one more output, one more table included here, which would show residual covariance matrix. So here we are computing. So in few seconds, I guess we would get a result. And there would be also one more option. So I would go once again here to these outputs, to these inputs, and go into advanced. And not here, sorry, it is in plot section. And there is also one more option. No, it's not present here, sorry, it's only in structural equation modeling, I guess. So here we have only this one output, this table. So if I go to this output, I can see here, that's the residual covariance matrix. So that's the output for residuals. And here we have the differences between real covariance matrix observed in my data and between covariance matrix which is generated by my data. Unfortunately, to compare these covariances, it's slightly problematic as covariances are every time linked to the scale of individual variables. So what is big or small, it is quite difficult to say, but all these values should be close to 0. That's general recommendation. It seems quite good for this option. And if you would like to see another result, so it means a result for better diagnostic, we need to switch into general structural equation model settings in JASP. So if we would like to switch to SEM and we wouldn't like to write all commands for this model, so it means all these measurement models for flat right, liberal conservative, and some more options, I can ask here in, I guess it is additional output. Yeah, additional output for Lavant syntax. So I can go down and JASP will prepare for me commands for this CFA model. So if I go down, it should be last one output for JASP. Only I need to wait a minute, I guess, as JASP is still preparing the commands. So now it seems good. And you can see how JASP is describing factor model. So it would say that the factor model is created by equality sign and tilde, the first 5 items, and every factor loading is called lambda 1, 1, lambda 1, 2, etc. up to lambda 1, 5. Factor 2 is created by lambda 2, 1, lambda 2, 2 multiplied by A47F up to A47K. So that's definition of 2 factors. And as I'm also expecting that A47D and A47E residual errors are related, that's why there is also residual correlation section here. You can see also these crosses before the word factors and residual correlations. And this is settings for nodes in our language. So if you type the cross, you can add your commands, and R or here JASP through R will not use these words as commands. So I can copy this syntax, and we can skip into structural equation model settings. So I would ask for SEM, general SEM. And I would show you also another output for residuals in this general SEM procedure. So I can copy here the Lavant syntax we have just prepared by CFA. And if I go down here, I guess it is in advanced. So for options, statistics. Here it is, residual covariances observed fitted. That's not the output, so I'm not able to find this output I would like to see.
Excuse me, Professor.
Yeah.
Could I ask you?
Yeah,
I'm quite lost. I don't know where to find model syntax. Could you show me where to display it?
Of course. So here we go through CFA into the last one, advanced, sorry, not advanced, but additional output. And here I would ask for show Laval syntax.
Thanks a lot.
Yeah, and here, if you ask for this output, so you would find the last output model syntax, and I can click here into this small triangle and copy.
Yes,
and then
amazing. Thank you.
I can skip, but only I'm not able to find the output I would like to see. So I would once again go to SEM. So here we are. So statistics, additional fit measures, fitted residuals. So these are once again the same output as we covered previously. For options, there is no such output. And for advanced, so sorry for that, but I'm not able to find it. I will try to find it during the break and to show you where it is hidden. I guess it is in JESP included. So currently I would switch once again to the presentation. And I would like to ask you for your own CFA practice. So there is one Microsoft Word file prepared for you, which is called Cfa Practice. So I would open it and through this Cfa Practice, you should take the similar model as we have just covered. So it means you would compare model with two uncorrelated and two correlated factors. Only these two dimensions you would use for this task would be slightly different. So you would be using data file which is called 11 UVS 99 CFA. And if I open Microsoft Word file, so here it is. It is a brief description of data that are available for you. So I would make it only bigger. So you should expect two dimensions in your data. So there are three questions about homosexuality, suicide, and euthanasia. These are three questions that are expected. They would be related to each other. The next three items, once again, related to each other is cheating on taxes, accepting a bride, and state allowance without entitlement. So it is expected that these first three items are something like some private behavior explanation and public behavior explanation. And you should try to perform CFA for these two dimensions and try to find whether these two dimensions could be unrelated or related. That should be the next task for you to compare two competing models. Names of variables should be like these. There are also some other variables, but they are not necessary. Only before you start to compute in JESP, I would like to recap that if you like to perform CFA in JESP, all variables should be as scales. So if they are not defined as scales, first of all, you must define these as scales. You can see that first three items have minimum max 110, so they are quite long, so they are real scales. Cheating on taxes and other these violet items are from 1 to 4, so they are ordinal scales, but still it is possible to treat these as scales for our purpose. So in the next 2 minutes, next 10 minutes, you are expected to compute this CFA for these two related or unrelated dimensions. Some questions related to this task?